Hey everyone, we're back, and here we're looking at the unit circle. Everything we've done the past couple of lessons has brought us to this point. Now the unit circle is going to help us determine the sine, cosine, tangent values at really special angle measures that are out of our 0 to 90 range. So for example, it's going to help us know what the cosine of 300 degrees is, or what sine of 4 pi over 3, what that value is, or even tangent of 3 pi over 2. This is going to be able to help us determine what that value is. And before we get into this, I would like for us to recall a couple of things. So in a previous video, we saw that we can use all students take calculus to help us know when the various trig ratios are going to be positive. So in quadrant 1, where both our x and y values are positive, all of the sine, cosine, and tangent ratios will be positive. Whereas in quadrant 2, where we have negative x values and positive y values, only the sine ratios will be positive. And we go to quadrant 3, where both negative x and negative y, only the tangent ratios are positive, and quadrant 4, where we have positive x values, negative y values, only the cosine ratios are positive. So we need to remember this. We need to remember which quadrants lead to positive trig values. Okay. Also, I would like for us to recall that in a unit circle, one reason why we call it a unit circle is that the radius here is going to be 1. So we've seen before how we can write cosine of an angle in terms of, x divided by the radius. Well, here, since the radius is 1, we're going to say that cosine is equal to x. That the x value on the coordinate plane here is equal to the cosine of the theta. And then sine of theta, with a similar argument, we can say sine of theta is equal to y. And we've seen this before. And then with that, we know that tangent is y divided by x. But this is interesting. If sine of theta is y and cosine of theta is x, could we not say tangent of theta is actually sine of theta divided by cosine of theta? That's actually what we call a quotient property, a quotient identity. The tangent can be written as sine divided by cosine. So we have where we can know whether the trig functions are positive or negative. We know here that our coordinate x comma y, we can rewrite essentially as cosine of theta comma sine of theta. And also, we've seen in previous videos how we can memorize the trig values for between 0 and 90. So there's a table, or you can also use our hand. So the table you can see on the screen here, and I'm going to leave it on the screen here for a little bit because we're going to use that table to kind of help us form this unit circle, okay? So keep these in mind as we fill out this unit circle. So what a unit circle is, it is a visual that helps us know the trig values between 0 and 360 at certain angle measures. So we began by looking at 0 degrees, which we're going to also say is 360, we know that. In radians, that would be 0 pi or 2 pi. So we went from there. The next angle we saw was 30 degrees, which we know to be pi over 6. And then we saw 45 degrees was next, which is pi over 4. And then we have 60 degrees, which was pi over 3. And then we have 90 degrees, which is pi over 2. So keeping these in mind. And before we actually look at what the trig values are at these angle measures, let's extend this, because one part of the unit circle is we're going to have to know what are the angle measures above 90. Okay, so here's one way of learning where the angle measures are placed. Okay, so I'm going to start with the 90 degrees. So we know 90, the next one would be 180, and going from pi over 2, adding another pi over 2, that would be just pi, and we should know this. And then looking at adding another pi over 2, that would be 3 pi over 2. Or that would be adding another 90 degrees, that would be 270 degrees. And if we add another pi over 2, we'll get 2 pi. If we add another 90, we'll get 360. So I started with 90, I just kept adding 90. And for pi over 2, I just kept adding pi over 2. So let's kind of work backwards with that. So looking at 60 degrees. For 60 degrees, I'm going to use this other nice looking blue. So for 60 degrees, to determine the others, I just keep adding 60. So 60 and 60, that'll bring me here. That's 120 degrees. Or pi over 3 plus pi over 3 is 2 pi over 3. All right? And then I add another 60, that brings us to 180. Add another pi over 3, that brings us to pi. So I add another 60. So I add another 60, I get 240. And then add another pi over 3, I will get 4 pi over 3. All right, so adding another 60, that would bring us here. That would bring us to 300 degrees. And then adding another pi over 3 would bring us to 5 pi over 3. And then if I add another 60, we get to 360. If I add another pi over 3, that's 6 pi over 3 or 2 pi. So that's one way of knowing this. Another way of knowing where my 60s go is using a geometric mindset. Is I take this point and 60 reflected over the y-axis will land me here. So that's another angle measure that's relative to the 60 degrees. And then reflect that down. So another angle measure that's relative to the 60, reflected over. It's another relative to the 60, and so on. So if you were to connect these 4, we would essentially see a rectangle. Okay? So that's the 60s, so if I do 45. So the 45s, I'm going to use this nice yellow. So the 45, I add 45, get 90. Add pi over 4 plus pi over 4, I get pi over 2. So add 45 again to 90, and we get 135. Same idea. The 45 gets reflected over, so that's how I know where it's going to be placed. So then I add pi over 4, and I get 3 pi over 4. Add another 45, we get to 180. Add another pi over 4, we get to pi. So I add another pi over 4. That would bring us to 5 pi over 4. And knowing where it goes because it's reflected down from the one above. And then 180 plus 45, that's 225. Adding 45 again brings us to 270 and 3 pi over 2. Adding 45 again brings us to 315, which is reflected down from the 45 above. And then adding another pi over 4 brings us to 7 pi over 4. So pay attention. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. So if I would write them without simplifying, they would just increase up to 8 pi over 4. So now looking at pi over 6. So with pi over 6, there's some overlap. So if I add 30 degrees, I get to 60. So we already know that. If I add 30 again, nope. Add 30, nope. So if I add 30, here we go. So I get 150. Paying attention, it's right across from the 30 degrees. So I have from there, in terms of pi over 6, let's say 1 pi over 6, 2, 3, 4, 5 pi over 6. Okay? So 5, it's 6 pi over 6, 7 pi over 6. Adding 30 to 180 gives me 210 degrees. Adding 30, so that's 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, or it'd be 330 degrees. So in terms of, we have to memorize, in terms of memorizing this unit circle, we have to know where the angles are. That's one part of doing this. So when learning this unit circle, you need to know where the angles are placed, okay? Eventually, we'll just need to know which quadrants they are in, but we need to right now know where they actually can be placed here, and we'll have practice with that. So now, what do we do with the sine and cosine of all of this? So the sine and cosine of all of this, let's start with, the 0 to 90, 180, 270, okay? So using our table as we see, so we know here that cosine is x, sine is y. So in our table says that cosine of 0 degrees is 1, and sine of 0 degrees is 0. So this would be 1 comma 0. So then cosine of 90 on our table we see is 0. And sine of 90 on our table we see is 1. All right? Now, continuing that. So if I look at 180 degrees, so I knew that cosine of 0 degrees is positive 1. So on the other side of the y-axis, where cosine is negative, cosine of pi will be negative 1. And where sine of 0 is 0, same here. Sine of pi is also 0. So when I'm writing these coordinates down, understand, remember, the x, what we thought of was x, is our cosine value at that angle measure, and the y values we're seeing as our sine values at that angle measure. So I continue on. So with 270 degrees, zooming out just a little bit if I can. There we go. So with 270 degrees, where cosine is 0, at 90 degrees, cosine is still 0 here. But where sine was positive 1, being below the y-axis, sine is now negative 1 at this value. All right? And then let's look at the 60 degrees. So I'm just going to write these in real quick. So from our table, we know cosine of 60 degrees is 1/2. And from our table, or from our hand trick, sine of 60 degrees is 3 pi over 2, or square root of 3 over 2. So I'm going to use that to complete the remaining matchups with 60 degrees, okay? Now one trick, I'm going to share this with you. One way to know how 60 can be related to the other quadrants is by the denominator of the radians, okay? So if I look at here, I have a pi over 3. Every other radian that's out of 3 is going to be relative to this. So if I were to drop a reference triangle here, the angle that we would see from that triangle would be 60. If I brought a reference triangle up here, our angle would be 60. If I did it over here as well, for about my reference triangle up, my angle would be 60. So these 4 locations come back to the 60 degrees. But again, you can see this by looking at the denominator of radians. But what if you have your degree, your angle measure in degree? Well, why not convert your degrees into radians and just use that, because that will help us to identify. All right. So with that being said, let's say I want to know what my values are at 2 pi over 3. We know that in this quadrant, cosine will be negative and sine will be positive. So my point becomes negative 1/2 and negative square root of 3 over 2. And then in our third quadrant, where we have x values that are negative and y values that are negative, both cosine and sine are going to be negative. So here we're going to have negative 1/2 and negative square root of 3 over 2. And in the fourth quadrant, where cosine's positive, or x is positive, and y is negative, I would have a positive 1/2 still for my cosine value, and a negative sine value. All right? So I simply use my first quadrant and use my understanding of how they change in the different quadrants to just fill them in. So I did this pi over 3 all at once. So now into the pi over 4, or 45 degrees. So with pi over 4, from our table, we know both sine and cosine are the same value. So both square root of 2 over 2. So with my same reasoning, I'm going to look at the angle measures that are out of 4. All right. So second quadrant, cosine's negative. Sine's positive. All right. In our third quadrant, both are negative. In our fourth quadrant, only sine is negative. So again, sine being the y value. So we did that very quickly. Knowing what we have from 0 to 90, we did the remaining. And then on to 30 degrees. So with 30 degrees, we know with 30 degrees, cosine is going to be square root of 3 over 2. And sine of 30 degrees, or sine of pi over 6, is going to be 1/2. All right, you ready for this? Let's try it out. So cosine's negative, second quadrant. But sine remains positive. All right. Third quadrant, each is negative. Fourth quadrant, only sine is negative. And with that, we have our unit circle. So let me zoom out just a little bit again so we can see the finished product. And we have here the unit circle filled in. So starting with the angle measures, fill those in. I picked an angle measure that I knew in our first quadrant and just moved that around to the other 4. So how can we use this to do what we asked at the beginning, like cosine of 30 degrees, or sorry, cosine of 300 degrees. So cosine of 300 degrees, I know that that is in the fourth quadrant. So cosine of 300 degrees is in the fourth quadrant, so I know I'm going to have a positive value. So cosine of 300 degrees, converting that to radians, is pi over 3. So pi over 3, that's relative to pi, that's relative to this. So cosine of pi over 3 is 1/2. So cosine of 300 degrees is going to be 1/2. So let's say I want, sine of 4 pi over 3. So 4 pi over 3, that takes us to the third quadrant, and it's already in radians for us, that's good. So pi over 3, that's relative again to 60 degrees. So sine is 3 pi over 2. So in our third quadrant, sine's negative. So I could say sine of 4 pi over 3, which is relative to sine of pi over 3, is the square root of 3 over 2, but here in this quadrant, we would say negative square root of 3 over 2. And lastly, if I have tangent of 3 pi over 2, so tangent, you've noticed, we haven't been talking about tangent here at all. Tangent, we take our y value divided by the x value. So if I want tangent of 3 pi over 2, I would have negative 1 divided by 0, or undefined. So there's tons that we can do with this, but for right now, I ask you, work on memorizing this unit circle, where everything is placed, starting with the angle measures, then going with using quadrant 1 to fill out the remaining quadrants. And then ask yourself, okay, what is cosine of 7 pi over 4? Okay, so 7 pi over 4 is in the 4th quadrant, so cosine is going to be positive. And pi over 4, that's square root of 2 over 2. So positive square root of 2 over 2. Or what about, even better, what if I said, let's say I want the sine of 13 pi over 6. Okay, so that's right. So use an example. So example up here. So let's say I want, what did I say, cosine or sine? It doesn't matter. Cosine of 13 pi over 6. So that's greater than 2 pi. So that's greater than 2 pi. That brings me to the first quadrant. Pi over 6, cosine is square root of 3 over 2. And just like that, I have the value for that value. I have the value for that ratio. All right, so there's a lot here, but you're gonna take time right now to work on memorizing this unit circle. And because I could just easily say when you come into class, fill in the unit circle, and you should be able to, using these skills, do that. Okay, so I wish you luck in memorizing this. Watch this video again if you need to listen to those little tips that were given. I'll see you next time.